So, welcome to how to achieve actual GitOps with Terraform and Kubernetes. The reason why it's called actual GitOps is because no one apparently knows what GitOps actually is. So the thing is, they see the word Git and they think that they have stuff in Git, and then they automate it, and then you have GitOps, which is not true. So the reason for this talk is basically while being on the program committee for GitOpsCon, we got a lot of talks sent in that never actually explained that they knew what GitOps means. It was basically just, we have Terraform, and we're going to go do cool stuff with it, and it's going to be automatic. And we kind of go, but do you use GitOps? And say, yeah, of course we do. So that's why I made this talk. Who am I? My name is Robert. I'm currently the head of platform engineering at Crayon, and by currently I mean that I'm going on vacation on Friday, and then I'll return a new job. So I'm changing jobs. Talk to me later about that if you want. I'm a Microsoft MVP, a HashiCorp ambassador. I call myself a cloud automator because I like to automate clouds. You know, it makes perfect sense. I'm a very big supporter of open source. I am doing a lot of things in the cloud native space. I'm in the CNCF tag app delivery, doing a lot of things, among other being in the now renamed platforms working group, which was called Cooperative Delivery Working Group. Someone gave it a name and we never understood what it actually meant. What we actually meant was platforms. So we just changed the name, you know, perfect sense. I'm also a maintainer on the Open GitOps project, which is why I can talk about what GitOps actually is. And I'm doing a lot of things with Terraform in Azure. There's a new thing called Azure.tf. If you go there, you're not going to get anywhere. That domain doesn't lead anywhere yet. So hopefully soon. I do a lot of work with Cloud Native in general, and I'm one of the co-founders of the Azure Cloud Native user group. I'm also the founder and the only active member of the Norwegian PowerShell user group, which hopefully will have a return soon when I can find the time. And I'm also one of the co-organizers of DevOps Days Oslo, so if you're going there, I'm going to be there too. So that's me, really quickly. So the agenda, what is GitOps? So we all know what GitOps actually is. How to run Terraform with Kubernetes, and that's about it. The problem is that there's a demo now, soon, that didn't work earlier. And I've been, literally before everyone came in here, I was sitting on my computer and I managed to get it working, and I hope I managed to reset it so that it actually will work again. But we'll see. It is what it is. So, Terraform, stored in Git, automated with pipelines is not GitOps. That's like the short version. Just because you are storing things in Git and just because you are doing automation on what's stored in Git doesn't mean that actually GitOps. GitOps is a term that came originally from WeWorks in 2017, I think is correct. And it was kind of their way of describing what they have been doing internally. WeWorks obviously was the one that kind of that started with Flux, which we'll look at now, which is a true GitOps tool. And then coined the term, and then it went on to CNCF, and there's a GitOps working group that got started by WeWorks, Amazon, Google, Microsoft, CodeFresh, Red Hat. Ooh, I almost forgot someone. And then later on, well, Crayon was part of it because, you know, me, hey, I'm the only one that was part of that. But anyway, that's what it says on paper. So the Open GitOps project had tried to make these what we call the GitOps principles, which is a descriptive way of actually saying this is what GitOps is. Not going to go really in depth, but it needs to be declarative. So the things that you put in there needs to be declarative format. So you just say, I want this. It needs to be stored somewhere where it's versioned and immutable. There, you know, the current version is the current version. If you need to change something, you need to put a new version in. It needs to be pulled automatically. So everything that you put in there is what is going to, what's going to happen on your platform, and it needs to be continuously reconciled. So it needs to attempt to make so that what's stored in Git is actually what's going on in your platform of choice. So those are the principles, and in itself, it doesn't actually say that it needs to be Git. It just happens to be the fact that Git is an actually really good way to store things in a versioned and immutable way. And it doesn't have to be Kubernetes. It just happens that Kubernetes is kind of built around the notion of controllers, which then kind of leads to or lends itself well to this kind of practice. The tooling we are going to look at is, like I said, Flux CD, which, like I said, controllers. We have a lot of different controllers here that are working in unison. We have a source controller that looks at your Git repository or your storage account or S3 or whatever that can fill those specifications. That takes in what's happening in Git and puts it into the Kubernetes API as a resource. And that there are different resources that are created that comes from Flux using custom resource definitions. We're going to look at that. And so basically, we're just extending the Kubernetes API with new resources, which the source controller looks at from, you define your where it's stored. So source controller knows where to look. It sees that there's a new, for instance, like a manifest. So it updates, upset that in the resource, the CRD from Flux that deals with that. And there's a customized controller that kind of does your kubectl apply, basically. There's also a Helm controller for if you're doing Helm stuff, and there's an image controller if you are referring to a OCI image and you want that to do automatic, polling and everything like that. But we're not going to look into that specifically. For those who don't know Terraform is declarative, which kind of works with this GitOps mentality. It's modular. Every single piece of Terraform that is in a folder is basically a module. So if it's where you're running Terraform, that's a root module. If you have, for instance, things related to setting up a VM or a Kubernetes cluster and have that in a folder somewhere else and import that into your root module, it's a resource or child module. It takes inputs and exports outputs and has a state file. So everything that's happening with this root module will get stored into a state. This is where it kind of gets tricky in many cases, because when you do automation, for instance, like pipelines, you need to be able to put that state file somewhere where everyone can reach it, because you can't have several state files with the same content with separate owners. That doesn't work. So what we need from Terraform in Kubernetes is that we need Terraform modules as a resource object. We need to have lifecycle management, so it needs to take care of the state file. And we need it to be able to be dependent on other root modules. So if you're working in big scale Terraform, you usually have some sort of resources that are maybe like the base platform, some shared resources. That needs to have its own life cycle, while you might, another team might supply different resources on top of that, and that's kind of how you build your platform. So we need to have dependency on other modules. And the root modules need inputs and outputs. And luckily, that's the end. Look, yay, great. Now we all know. Luckily, WeWorks, who, like I said, created Flux, started creating what they call the TF controller. If you look at controllers or operators for Terraform, you'll find a lot of different ones. But so far, the best one, in my opinion, has been the one from WeWorks, and it's in active development. So there's, some moving parts there. Hopefully, it doesn't break. But in itself, it's more stable than what I've seen other people have done. And I also seen them doing like experiments with 1,000 concurrent Terraform root modules run independently in a big cluster. So they're actually getting good performance out of this as well. I'm going to show one easy demo, and then I'm going to show something that might break. The first one I did on GitOps Day, so if there's text that says GitOps Day, sorry, forgot to update it. But basically we have there it says GitOps Days. We basically have a very simple Terraform file, which has 2 variables, which is your inputs, and it has 1 output. And the idea behind this is that you supply this input, and then you want to store the output so you can reference it, you can look at it later on, and so on and so forth. The best part about this is that it doesn't require anything. It just requires us to run Terraform. You know, there's no dependency on platforms and logging credentials and stuff like that. So this is why this is an easy demo. To run this, we create a Terraform object. And this is a custom resource that had come from, obviously, the Terraform controller, which it says greet GitOps stays here, but that's actually not what it says when it comes in because I'm in the wrong branch. You know, just ignore that. But you can see here we have the interval, so you know how often should it check. It also does drift control, so if someone does something outside of Terraform, it actually checks that and says, oh, you know, something has gone wrong here. Someone's doing stuff manually. You know, they shouldn't. So it actually will run Terraform and restore it to the current state it should be. I set it to approve plan auto, which just means that if it runs and it needs to do an you know, Terraform apply, it will automatically deploy it. But in this case, it's pretty easy. Like I said, it's basically just going to have the inputs, and then it's going to store the outputs. And let's see if it works. So I have an empty cluster, I think, hopefully. And can everyone see what's going on here? We have one terminal down here. That might be actually a bit too low for people. I'll do this. You'll have a worse K9S experience, but hopefully a better general experience. Like that. All right, so what we want to do is, first of all, to use the TF controller, we need Flux. The TF controller is actually working in conjunction with Flux. It actually works together, it's not a separate thing that you can just deploy. You can do that, but then you have to do a lot of things that you know, is out of the scope for that one. So first of all, we need to do a Flux bootstrap. I've stored a GitHub token in my environment. So when I say that I want to do a Flux bootstrap GitHub, which means that I want to add a Git source that's from GitHub, putting in the owner, which is me, my profile. If it was a company, you would have to put the name in there, but at that point, you don't have to put the dash personal at the end. I pointed to a repository and a branch and a path. So if we go back here, we'll see that in the manifests one, we have this greeting folder. So it's basically just going to point Flux against this particular file. Ignore the VM file, it's not actually there. If we do that, and hopefully everything works, we will start to see stuff happening. If I do namespace, I can go to Flux system specifically and see the pods that are now running there. We have the Helm controller for doing Helm stuff. We have the customize controller for doing, you know, customize or just plain manifest stuff. We have a notification controller, so if we want, we can get notifications about changing of state and everything like that into Slack, into Teams, into whatever. And then there's obviously the source control, which makes sure that, you know, we are looking at some sort of source. Makes perfect sense. And I didn't get a warning. And the reason why I didn't get a warning, which I usually do, is because since I already installed the Terraform controller and I purposely didn't remove too much, I have a CRD called, well, actually now it's pretty far down, Terraforms. And then obviously now we have a lot of other ones because this comes from Flux itself. So this is how it keeps track of what the controllers are supposed to do. If I now look for the Terraform resources, we have one called greet folks, which used to be greet GitOps. It doesn't do anything because there's no TF controller here to do anything with this. So nothing is actually watching this. So hopefully now, if we if we are lucky enough that it works, I'm going to install the TF controller, and that's going to look at this resource and see that there's stuff that needs to be done here. We can also just to make sure, if you look at the secrets, we have one for Flux system stuff. So the idea is that the outputs that this Terraform file is supposed to generate is going to be put into a secret. So hopefully that will happen. Let's go over there, install that. It doesn't exist, installing. And hopefully now we should see that there's going to be some status updates. Hopefully. Oh. And as you can see now, it says reconciliation in progress. So it sees the file, it sees how how you explain like how the Terraform should look. If we now go into pod and hopefully get it before it goes away, we can see we are actually in a pod running Terraform. And it's done. And it says here, the message is supposed to be salutations, folks, not GitOps days. And there's generally a lot of information here that you can choose to ignore. But if you're doing if you've done Terraform, you can recognize a little bit of this, like you initialize it, you're doing a plan or a apply or whatever. And as it says here, apply complete. There's 0 resources added, changed, or destroyed because there's no resources there. We're just like playing with Terraform itself. But if you look at the secrets, there's now a greetings output, which if I decrypt says salutation, folks. So now we actually have a working process. If I now in this repository put in new YAML files that define Terraform, it would actually be picked up and used. Now, for the hard part, this is okay, right? It's perfectly fine. But the thing is that when you're starting to do Terraform for real, you're not just like having inputs and then putting out an output. You actually have a lot of resources. You have interdependencies. You have things that are, interconnected in many ways. So I created a dependency demo, and dependency is a new feature actually. What it basically that you do, I can actually show it. You can have a Terraform resource like this. In this case, I'm referencing also Terraform Enterprises, but Terraform Cloud. And the reason for that is the runner itself doesn't have basically anything. It has Terraform on it. You can supply your own runner. So you can have, like, if you're doing Azure, you can put in the Azure CLI tool to have that kind of process. The problem is, obviously, you have to host it yourself, and then so on and so forth. We'll see what happens with that later on. But if you are using, for instance, like Terraform Cloud as a backend, the actual run will then run on Terraform Cloud, which has everything that you need for that, right? So for this demo, I'm just going to use Terraform Cloud, just so I don't have to do a lot of more technical things that will break. And as you can see here, we have some variables, a deployment name, location, and I'm going to write some outputs to secret. And the reason for that is because if you look at the workload, so this is what I call shared resources. If you look at the workload one, it says here it's dependent on the shared resources. So this will not run until the shared resources Terraform root module is in an active and OK state. And the reason why I do that is because I have I have some variables from secrets. I have one secret called workload secrets just because I need a password, for a VM. I'm doing a VM, so I need a password. But I'm also doing 2 other things. If you look at the actual Terraform code, one of these, there is a subnet ID, which I don't know. I don't know what that is because that's part of the other Terraform run. And I also have a resource group name, which is also done in the shared resources one. So what I want is to get this supplied from the other Terraform lifecycle, so to speak. All right. I have a note. Let's see if I can, let's see if it works. And yes, there's spelling mistakes, I know, because this is not words. All right, so first of all, I have this, and it's probably my own fault that everything's so hard. I have everything in a different branch. I haven't merged stuff into main. So if I did, this probably would be easier. But since I don't have that, I need a new Git repo source, because as you can see here, it's referencing the URL, which is fine. But if I look at it, and hopefully you can see that really quickly, maybe somewhere down here, there's a reference to branch here. So this object references to the main branch, period. So first of all, we need a new Git repo resource, and then we need a new customization resource, because stuff is in different folders. So we need to set up something. We need to set up the process from the customized controller where it can look into and understand which files it should be pointing towards. So we need to create those two things, which is where everything can go wrong, apparently. So if we look at Git repo and I paste in this, it shows up and it says true. All right. And then we need to create the customization. This is true, which then should create some terraforms, which is true. So you can see greet folks just did a drift check. There's no drifts. And we can see that workload 1 has a dependency on something else. Oh, and this is good. That error is good. That means it's working. Ignore that error. So you can see here that the workload 1 is false because it's dependency on a different resource which is not ready. What we also can see is that shared resources says, I don't understand anything. And that's because we haven't created secrets for the Terraform cloud. So there's no tokens, there's nothing for it to use, which hopefully might not be a problem. So I have a file here. I'm not going to show it because then I will show off my secrets. So I created that, and I'm also going to create a secret. And even though there's password here, you know, it's not gonna. It's fine. This machine is going to be gone. So I created the two that I needed. If I look at the pods now, nothing is happening. But if I look at our greet folks jumped up. If I look at the Terraform again, it says still has the old message, and I put it to reconcile every 1 minute. I'm kind of inclined to just let it do that because every time I try to push it, weird stuff happens. But what you can do is use flux reconcile customization and then the name. Shall do. Yeah. Also, this can take a little bit of time. So if anyone has questions while we're waiting and praying, then this is a good time to do it. Especially since nothing is happening. Yeah, Flux over Argo CD, that's kind of the thing that you always come back to. So for those who don't know, Argo CD is basically the same setup, but executed in a different way. It's more graphical. You get a dashboard. You can see things a little bit more clear. Not so much these controllers happening in the cluster, and then you have to kind of look into it for yourself. WeWorks have tools to visualize things. It's just not part of the Flux package, so to speak. And the reason why they went with that is the way that I see it, it's more of we just want small processes that works, and we want it to be as hands-off as possible, which is why, for instance, Flux is the tool that's used from Azure. So AKS now comes with a GitOps add-on, which installs Flux. It's basically just preference at some point. I like Flux and the way that this is doing, but I don't necessarily dislike Argo. It just happens to be my choice to do it like this and not have the visualized things. Okay. Okay, so what I can do, I think, is do a Flux reconcile, source git, yes, dependency demo, which might do something, or else I'm going to start deleting stuff directly in my cluster as part of the demo. 3, 2, 1, no, okay. Yes, this is totally, and it says reconcile now, but because it's trying to delete it, or maybe not. Let's see. Let's look at the pod that's running now. Shared resources might say something like memory error. Yeah. Yep. Okay, so that's not good, but it's kind of what I expected, and that's, I think, because there's a finalizer here. So I'll just remove it. You know, we solved everything. Which hopefully also removes this. And then we can do a new reconcile on the get source and see if there's changes happening. I kind of want this to be gone though. Yeah, crash loop, go away, terminating. Does this have, no, okay, don't change things. All right, cool. Yep. So I wish I could say that my workflow is perfect and every time I do something, it just works. It has a tendency of not being that way. And there is actually a term, I'm just going to talk while this is happening, hopefully. There's the term that probably some of you have heard, which is yak shaving. You know, because, you know, it's doing stuff. Shh. Okay, so, you know, yak shaving just means to shave a yak, it's a big hairy animal. You can't just shave it in one go, you have to do layers. So every time you do this kind of troubleshooting stuff, oh, wait, sorry. We have to shave in layers, that's the kind of idea. Okay, let's look at the runner. Oh, it's doing stuff. Whew. I think this is just so hard because I started putting in more variables in here that probably shouldn't be, like doing it in different branches. But the backend here is Terraform Cloud, not that way, this way. So if we look at, for instance, like the shared resources, which is running now, there we go. I'm referencing an organization in Terraform Cloud and a workspace. If I look at that workspace, which is somewhere here, oh yeah, we will soon be able to see. So we can see here it says 3 to add. If you do Terraform in CLI, you'll see this, right? And you can see that it also puts out the resource group name and the subnet ID. What actually happens now is that it did a Terraform plan, and it sees that, oh wait, there's stuff that needs to be done here. So now it actually is doing a Terraform apply, which then does a Terraform plan again, which is why I need to be able to talk while this is happening, because it actually kind of takes a little bit of time. If I go the right direction, we should now be able to see that it did a plan and finished, and since there's changes that needs to be done, it's doing an apply. And we can look at it here, or we can look at it directly in the, so it, you know, exactly the same type of experience that you have if you run Terraform on your machine. It just happens in a pod, and the TF controller keeps track of all these pods. So if you have, you know, 600 Terraform resources, it will, you know, have its own life cycle and run pods, you know, at scale, and you'll be able to deploy whatever you want in this fashion, and it shouldn't matter. But like I said, the main problem comes when you're doing this and you need to actually be interdependent, like you need something from something else. So now, hopefully, when it's done running, which is why if it worked the first time, we would be done by now. But so it basically just creates a resource group. It creates a network security group because I need that. It creates a virtual network. And that's all the shared services you're going to get, so, you know, deal with it. And then we'll take a virtual machine and put it on that subnet and in that resource group. So 2 separate life cycles. So that finished. Good. And now we can see it, you know, end of file because it stopped. And if you look at the TF one, you'll see that it still says reconciliation in progress. And I noticed that it kind of does that before it needs to run another plan, apparently. I don't know why. There are some kinks to be fixed here. But as soon as it does now, it will say there's no change. So the status will be ready, true, hopefully. And as soon as that happens, the next one will see that the thing that I'm dependent on is actually done now. So now I can run and do stuff. And while that is happening, another way. This one, like I said, it has a couple of the same type of variables, but it also have the subnet ID, resource group name, and admin password variables. And if we look at the file itself, we are supplying deployment name directly in the as a variable in the file and location as well, because why not? And then we are importing the admin password from a secret, because it should be secret. And also, since we have the outputs from the other Terraform in a secret, we also import the variables from that all the way. And hopefully this is true, because or else we're going to stand there for a long time just... Oh, true. All right, cool. No drift, which then should mean for workload 01, it's okay to run now. Everything's like it should be. And there you go. So that's interdependency. Obviously, this is just like another step. You could have separate Terraform, Terraform root modules doing separate things that aren't dependent on anyone. And they will obviously, as you can see, the Grid Folks one is continuously trying to reconcile and making sure that everything's as is. If we updated that file in Git, that will then get pulled in by Flux, and then the Terraform controller will see that the Terraform object is updated, so it does that for you and auto applies. And obviously you can have it to not auto apply and everything like that, and you can do manual approvals if you want to. But if you're doing a GitOps process, the idea is not to approve the change. You're approving it before it actually comes into the Git branch. So testing, making sure that everything's all right, that happens before you merge it into your main branch or whatever you're deploying from. When it's in that branch, that is what it should be out in the system. That's the GitOps way of doing it. And now it's applying. So. Cool. Any questions while we're staring at a console? Yes, sir. You could just yell.
I'm good at that. Yeah. All right, so we talked about the whole GitOps terminology here, and yeah, we usually make changes to your Git repository, and it's reflected in Kubernetes, right? Mm. Let's talk about customize.
Yes.
And versions of customize inside of Flux versus what you do on your laptop or wherever you test this stuff before you push it to your cluster. How do you do that in a reproducible manner?
So actually, customize in itself work exactly the same way in this process as it would on your machine.
Yeah, and that's kind of the problem, because if you run a diff with this, like you use diff or kubediff or any other tool, you'll notice that Flux actually adds some stuff. Mm. And if you have a different version of customize on your laptop or wherever local development environment you have, Flux actually bundles a different version.
All right. Is this something you have experienced?
Yes, it is.
All right. Yeah.
It's just why I'm asking.
Yeah. I have not experienced that, but to be honest, when I do stuff like customize and things like that, it's usually just very easy reference to specific files, and I have not seen that happen. Flux adds stuff on the object itself because it needs to keep track of it and do all the magical things that they figure out they need to do. But usually for me, it just happens to be that I kind of just do normal manifests if I do that. And I happen to use a lot of Helm also, so that's a different process again. But it's interesting that you have had that issue, and it would, if you want, let me know. And I can bring it to the people who create the tool.
Yeah, that's why I'm asking, because we also end up going away from customize for that reason, going back to normal, manifests. Yeah. Just to be able to do the diffs properly.
Every single example that you see on the Flux website is using customize. They're trying to get away from that because it makes it confusing for people that don't understand what customize is. And for those who don't know, it's just a template solution for making these things. There's a lot of things. Look it up. Which is why it shouldn't be like an introduction example for Flux. But they are using it. I know that Chanwei, who creates the Terraform controller, uses customize for his demos. I haven't heard anyone have that issue. So let me know, and I can talk with the people at WeWorks, and we'll probably figure out what's going on. Yeah, well, if it's the same thing with Argo, then there's something going on somewhere. Because I actually done specifically customized with Argo and Flux, and I've never seen that happen. So it's an interesting use case. Yeah. So apparently you're doing it wrong, most likely. No, let me know. Well, we can look at it and see if we can figure something out. Because Kustomize is a great tool. If you can use it and want to use it and you learn to use it, you should be able to use it in this process. Okay. Also, as we see, workload 01 has been applied successfully. So it's working. It's hard. Technology is hard. Yeah, there's not a lot much to say about that. I can go back and look at my many done workspaces. But you can see the workload 1 also happens to be run. He created the network interface for the VM, which needs the subnet ID, and it has the VM, which needs the password. And that's basically it. So, and as you can see here from the variables, I have some variables down here that are related to actually deploying stuff. So it has access to do that. But I haven't supplied a subnet ID variable or anything like that. Happens in the process for the TF controller, because it basically just runs Terraform and uses the setting the variables in the CLI tool. That's basically what's happened. All right. Any more questions? Repeat customer or repeat offender, depending on the.
Yeah, well, I know this talk is about GitOps and Terraform, but what about GitOps on crossplane?
Yes, that works.
How would you compare them?
The reason why I end up doing Terraform is because that's been my main way of doing infrastructure as code. Also, from a Crayon perspective, this has been like the common tool for all our consultants and in all our projects and so on and so forth. So using that same, like that build-up knowledge base just makes sense. We can create our root modules that are designed to do large-scale deployments and so on and so forth. But at some point, we kind of need some better process to do deployment of it, which is where this comes in. And when it comes to crossplane is really cool, but it's still, it's a work in progress is the wrong thing to say, but it's still developing. Things are still happening there. I feel personally that Terraform is much more it's an ecosystem that's been around for a while, and it works. So if you're doing, what people usually would say, if you're doing like 100% cloud native and immutable infrastructure and all of that, Terraform is kind of like a step in the middle thing. You use it for pipeline stuff and so on and so forth. This kind of proves that it doesn't have to be like that. It's still a viable tool for actually doing the deployments, and we can automate it in a cloud native fashion. So crossplane is good, but I personally use Terraform.
Okay, working in a platform team with supporting a lot of different teams, we use Terraform a lot, but our workflow is often that we need to approve a merge request. We use a pipeline, but it's all Git-based. But the problem is that we need to push that button to actually approve the pull request from the users. So the challenge is to distribute the control of the resources, because they're not our resources, and we want to give the users self-service. So that's where we looked at cross-plane as a way of you can give users the right to make sort of resource claims, and then you can add logic to evaluate. But can you scale this out? With a lot of different repos containing like resource specifications.
So you can set up Flux and any GitOps tool in many different ways. You can have, for instance, a base configuration repository where what should exist at all times lives, And then you can have different repositories or even just folders for different clusters or different teams, and give people access in that aspect. And you can set up Flux to look at specific folders and specific branches, like you kind of show now, but in a bad way. And you can do kind of that sort of planning. But if your users are not, Kubernetes people, what I started doing and kind of been working with at Crayon is creating an actual API for this. At that point, it's not GitOps, but it's an API gateway which you can say, create a new cluster, and it will actually create a new Terraform resource in Kubernetes with whatever happened. And at that point, you kind of have like self-service. But but at that point, it's not GitOps. If your people are used to Kubernetes manifests and the way that this works, how that works, this is a great way to get somewhere really quickly. Because using something like Flux or Argo CD basically just takes the entire continuous deployment part and it automates it. It's a system for it, so you don't have to think about that. And then the only thing you need to think about is the CI part, like what kind of tests are we doing? Are we linting stuff? Are we checking? If this file has some security stuff, etc. You can use OPA, for instance, to check your stuff, etc. Yeah. So that makes it just easy for you to do the CI part, which is kind of where usually that's kind of where it gets hard and gets tricky. That's kind of where you have different people doing different things. The CD part is just putting stuff out there. So that's kind of what Flux and Argo and these GitOps tools do. They do this continuous deployment part just by magic, so you don't have to think about that. So, but there's a lot of different ways to do that, and I know also, for instance, like Terraform Cloud now comes with a no-code solution, so you can set up your root modules, and then a user can get access and just say, it needs to be called this, it needs to have these things, and then you have your reusable Terraform code, I guess. So there's plenty of solutions, and also backstage, and so on and so forth. So there's many solutions to do like that self-service part. Which one is better, again, depends on your team and how you build stuff and everything like that.
Just a quick question regarding the depends on part here. So you currently have one, which is share resources. Does it support multiple? Can you have multiple dependencies? Okay.
It should. As you can see here, it depends on, it's actually a list.
Okay, yeah.
I haven't tested it, but it should. And if it doesn't, I'll have to do a pull request on some code at some point. But it should be able to just look at all the different dependencies and just checking them one by one. I actually haven't checked, so I'm not 100% sure. I'll never promise something that I'm not sure on, but it should. Yeah.
That's all.
Yeah.
This is probably a basic question.
Okay.
But because I'm not too familiar with GitOps as a term, for me it's a bit unclear what is the difference between having a controller polling for some resources versus having a pipeline triggered by a Git push.
Yeah.
For me, it's a bit hard to distinguish.
So the main difference and the one kind of like selling point of this is that if you're using GitOps, you don't have to think about continuous deployment. That is a process that is set up. If you're doing pipelines, you will need to set what triggers it. You need to set up, you need to check out your code. You need to do stuff on it. You have to do all of that, and you might have done that once, and then you kind of copy those files over. For me, it's like script sharing by sending it over email. I don't feel that that's like a good solution. It's what we have been doing.
Yeah, but that's sort of given that this just works. But it's a lot of complexity and just for getting this sort of basic example up and running.
Yep.
So for me, that's the argument is, I'm hearing sort of simplicity, but for me it's not that simple or easy. Yeah.
For example, because this controller specifically for Terraform is new. It's not anywhere close to. Well, you can probably use it in production. It's probably works just fine. But for instance, like the depends on is a new function, and I'm kind of pushing it a little bit when it comes to that. But I've been using GitOps for many years, a lot of customers, and in a lot of different environments. There's very rarely where it, completely crashed. There might be some hiccups on something that it kind of someone did something weird, except for you guys apparently who break it all the time. But from my perspective, it usually just works, and that's because that process makes sense. It's a very simple process, and it's based on what Kubernetes is built on. It's built on controllers and having that type of setup. So I would say in most cases and in most scenarios, it probably just works. You just bootstrap Flux or set up Argo CD and you point it toward a Git repository and you put your manifests in there and it works.
Yeah, we'll try it.
Yeah.
Okay, I think we have time for one more.
Down there.
Here the plan is set to auto. What if it's manual approval plan?
Yes, at that point, there's basically, if it needs approval, it just gets stored on the resource itself that this needs approval. And you could just update the resource itself, but there's also a CLI tool for that. And basically what you do then is just say that you can look at it, the plan will get put out in a secret, you can open that up and look at it, you can see all the changes on the resource itself, and then you could approve it manually in that sense. The state will be that it needs approval. So until that happens, it's actually not in an okay state. But again, it's one of those things where you can do that. That kind of is what people are doing with pipelines and have that kind of like, gatekeeping, so to speak. That's what the reason for me setting just to auto-approve is because at the point where it comes into Git, it should probably be what I want by that time, So, but you can do manually approvals if you want. And there's probably going to be a better way of doing that at the end. I don't think it's a big priority from the people at WeWorks because, supposed to do GitOps should be auto-approved.